Classify the following oxides as neutral, acidic, basic or amphoteric. Well, we have CO, carbon monoxide happens to be a neutral oxide. Wow. You have B2O3 and SiO2. Now, boron is a non-metal and non-metal oxides are typically acidic. So, you have B2O3 as acidic oxide. Silica and carbon dioxide, CO2 also is an acidic oxide, no doubt. SiO2 is very, very debatable. At times there are people who claim that silica is acidic. Why? Because it reacts with bases. At the same time, there is an acid called HF with which silica also react. Silica can react with acids as well as bases. Silica is classically amphoteric. Also, we have the rule that all the oxides of metalloids are amphoteric. Silicon is a metalloid, its oxide would be amphoteric. Al2O3 as an exception, because aluminium, although it is a metal, but aluminium, tin and lead, these oxides are typically amphoteric from P block to aluminium. Then we have PbO2, which is also amphoteric. Tl2O3 is basic. Oh wow. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We have done the classification. This is the answer. Write the suitable chemical reactions to show their nature. Well, CO plus HCl, no reaction. And CO plus aqueous NaOH, no reaction. So we say that CO is neutral because it does not react with either acid or base. B2O3, it is an acidic oxide. Why? Because it reacts with a base. You take NaOH and you just heat it. Okay, it forms NaBO2, sodium metaborate, like this. So acid and base react to give you salt and water. So B2O3 is typically an acidic oxide. If you take silica, silica plus NaOH in a very similar fashion can give you Na2SiO3 plus H2O. Yes, indeed. At the same time, silica plus HF can give you SiF4 plus H2O. So you can see that silica can react with base. It can also react with an acid to give you salt and water. So silica can function as an acid as well as a base. It is acidic with a basic oxide. It is basic with an acidic oxide, with an acid directly. So you can say that silica typically shows amphoteric nature. I repeat, although there are people who strongly believe, which is not very correct, I believe, that silica is acidic in nature. How can I justify what I'm saying? It's very simple. See, metalloids like silicon, germanium, in general, whenever you have any metalloid, oxides of metalloids are classically regarded as amphoteric oxides only. As non-metal oxides, acidic. Metal oxides, usually basic, and metalloid oxides, usually amphoteric. This is typically the trend. CO2. CO2 plus NaOH will give you NaHCO3. With more NaOH, it can give you even Na2CO3 plus water. So CO2 can react with base to form salts, but CO2 plus HCl, any acid, there is no reaction. So CO2 reacts with the base but does not react with an acid. Perfect. So it is an acidic oxide because it reacts with the base. Makes sense. Aluminium oxide, this plus HCl, Al2O3 plus NaOH. This is the fun part. What do you get? You get AlCl3 plus. So aluminium oxide reacts with an acid to form salt and water. Indeed. Aluminium oxide also reacts with a base to form a salt and water once again. Yes. So what is aluminum oxide? Aluminum oxide becomes amphoteric in nature because with a strong acid it behaves like a base, with a strong base it behaves like an acid, and the substances which do this are typically and classically termed as amphoteric. PbO2. PbO2 plus NaOH can give you Na2PbO3 plus H2O, just like silica. SiO2, same family PbO2. It can react to give you sodium plumbate. Yes, very much. The same PbO2, if you react with, say, HF, will give you PbF4 plus 2H2O. Reactions are very similar on very similar track. But I repeat, there are people who point out that PbO2 is amphoteric, but silica is acidic. I'm saying this because very popularly silica is quoted as acidic in popular common low-grade literature. Unfortunately, silica is best regarded as amphoteric only. Tl2O3. Tl2O3 is a classical base with HCl. It can give you TlCl3, or with HF it can give you TlF3 also. But same Tl2O3, if you add NaOH, you would get no reaction. It won't react at all.